Welcome back to another Orange Coast College mathematics video. In this video, we're going to continue our discussion of identities, and we're adding to our bank this set of half-angle identities. Now, really, these identities are actually the same identities as the double-angle identities in the last video. We're just solving for the half-angle rather than the double-angle. But really, they represent the same information. But sometimes it's useful to have them in this form. So let's go ahead and work through this. In this first example, we want to find the exact value of the cosine of 7 pi over 8. Now this is interesting because it says exact value, right? We're not using a calculator, but 7 pi over 8 does not represent one of our special right triangles or unit circle values. However, if I think of 7 pi over 8 as being a half angle, what is it half of? Well, if I multiply both sides by 2, I get A is equal to 7 pi over 4, and that is an angle in our unit circle. So I'm going to be able to find the cosine of 7 pi over 8 using the cosine or the sine of A. How am I going to do that? Well, I'm going to use the double angle identity, or rather the half angle identity for cosine, this guy up here. According to the half angle identity for cosine, the cosine of angle A over 2, or in this particular problem, we're talking about 7 pi over 8, is equal to plus or minus the square root of 1 plus the cosine of double that angle, which we said is 7 pi over 4 just now, all over 2. Well, we know that the cosine of 7 pi over 4 from the unit circle or your special right triangles, however you want to do it, it's in that fourth quadrant, and it's going to be that positive radical 2 over 2, the x value in the unit circle. So this is equal to plus or minus the square root of 1 plus radical 2 over 2 divided by 2. And we can simplify that. I'm going to multiply the top and bottom by 2 to eliminate those fractions within fractions and get plus or minus the square root of 1, that 2 distributes, 2 plus radical 2 over 4. And just a little bit more simplification, we can say that this is plus or minus, that square root of 4 on the bottom becomes 2, so this is the square root of 2 plus radical 2 all over 2. And now the only thing left to do is to determine whether it's plus or minus. Well, think about it. We're trying to find the exact value of 7 pi over 8. 7 pi over 8 is in the second quadrant. It's like right over here, a little bit less than pi. In the second quadrant, cosine is negative, so we're specifically looking for the negative square root of 2 plus radical 2 all over 2. All right. Just wanted to clean that up a little bit. In this next example, we're going to do something similar. We want to find the sine of x equals to, we actually want to make this a negative 1/4. If we know that the sine of x is negative 1/4, it needs to be negative because the problem is also telling us that we're in the third quadrant. We want to find the cosine and the tangent of x over 2. All right, so let's start going through it and see what information we need to ascertain. Let's say we're trying to find the cosine of x over 2. Well, again, according to this problem, that should be what? It should be plus or minus the square root of 1 plus, looking at this formula, the cosine of just x all over 2. Okay, so we need to know what the cosine of x is to do this problem. So let's take a step back for a moment and see if we can figure that out. We know the sine of x is negative 1/4. So that means I'm in this second quadrant, like the problem, or the third quadrant rather, like the problem gave me. And I know that I'm dealing with a sine value of negative 1/4. So that's a negative 1 with a hypotenuse of 4. Using the Pythagorean theorem real quick, I get the x squared value plus 1 squared is equal to 4 squared, which means x squared is equal to 15, or x is radical 15, plus or minus. Of course, because we're in the third quadrant, we're looking for a negative x value, so it's going to be negative radical 15. Okay, so really this problem, this cosine of x is going to be plus a negative radical 15. Over 4, because the x value is negative radical 15, but the cosine of x then is negative radical 15 over 4. Okay, in this next step, I'm going to simply multiply by 4 to get rid of these common denominators. This is equal to the square root of 4 minus radical 15 over 8. And the only thing we have to do now is determine whether it is plus or minus. But because we have now, it doesn't matter where x is, it matters where x over 2 is. So if we know that x is between these values, then x over 2 is going to be between all of these divided by 2. So I'm between pi over 2 and 3 pi over 4. So I'm in the second quadrant, making cosine still negative, and therefore I'm getting specifically a negative square root of 4 minus radical 15 over 8. All right, we still need to find tangent, so let's use the tangent double angle identity, or half angle identity. We have a few different tangent double angle identities up top. We're looking for tangent of x over 2. I already know both sine and cosine, so it doesn't really matter which one I use. We can just pick one. I'll use 1 minus the cosine of x over the sine of x, which is equal to 1 minus, we found the cosine is negative radical 15 over 4, over the sine, which is negative 1/4. I'm going to multiply by 4 over 4 to the top and bottom to simplify this a little bit. It's going to be equal to 4 minus a negative becomes plus radical 15 over negative 1, which is, of course, just negative 4 minus radical 15. And that will conclude this problem. Moving on to the next problem, we're back to verifying identities. So again, we want to pick a side to start with and then just proceed from here. As always, I like to start with the side that looks a little bit more complicated. So why don't we go ahead and start with the cosine squared of x over 2 minus the sine squared of x over 2. Well, I know from these formulas up here, I know what cosine and sine of x over 2 are. Cosine is plus or minus the square root of 1 plus cosine of x over 2. And now we're squaring it. Minus plus or minus the square root of 1 minus cosine of x over 2. Make sure my radical is covering everything here. And then we're squaring that. Which is equal to what? When I square that, the plus or minus gets canceled and the square root gets canceled, and I get 1 plus the cosine of x over 2 minus 1 minus the cosine of x over 2, which is equal to common denominator 1 plus cosine of x minus 1 plus cosine of x. Careful that this negative distributes to that negative, all over 2. And so I get the 1 and negative 1 cancel. I get 2 cosine of x over 2. Now, before you go just like canceling the 2's, let's take a step back and think about what we're trying to make this look like. I'm trying to make this look like the thing circled in blue here, the sine of 2x over 2 sine of x. Well, I already have the 2 on the bottom, so to get this sine of x, let's just multiply the bottom by a sine of x. Of course, the only way to do that is to also multiply the top by sine of x, so we're multiplying by something equal to 1. Well, that gives me 2 cosine of x sine of x over 2 sine of x. And oh, look at that. This top is the double angle identity from the last video. We know that this is 2 cosine x sine of x is just the sine of 2x over 2 sine of x, and that's what we were trying to show it was equal to. All right, let's try one more example to finish off this video. This one's interesting because it says to rewrite and simplify the expression without having powers. So the idea here is that sine of to the fourth of x is fairly simple, but we want to make it so it doesn't have powers. So it's just trig functions without like squaring or cubing them. Well, maybe a way to start this would be to just say this is sine squared times sine squared. That simplifies it. And these sine squareds are going to allow me to use a version of my double angle identity. We know that sine squared of x is equal to 1 minus cosine of 2x over 2. That basically comes from just taking these double angles and squaring them on both sides. Well, that's equal to 1 minus cosine of 2x over 2 times 1 minus cosine of 2x over 2. It does say to simplify, so what this problem is going to ask me to do next is say, okay, let's multiply these together. 2 times 2 is a fourth, and if I multiply these out, I have to distribute. I get 1 minus 2 cosine of 2x plus cosine squared of 2x. So because they wanted me to rewrite and simplify, that simplification caused me to have a square here that I still need to simplify further. So what am I going to do for that? Well, this is 1/4 times 1 minus 2 cosine of 2x plus, I know that cosine squared of x is equal to 1 plus cosine of 2x over 2. But in this problem, I don't have the cosine of squared of x, I have the cosine squared of 2x. Well, the cosine squared, if there's 2x instead of the x, then this x is 2x, and so I end up with 4x here. Just some scratch work. So this is plus 1 plus cosine of 4x all over 2. And for good measure, for simplification, we can multiply this 1/4 out. And so I get 1/4 minus 1/2 cosine of 2x plus 1 plus cosine of 4x all over 8. And if you really wanted to simplify fully, we can now write this fraction as 1/8 plus cosine of 4x over 8. And a fourth plus an eighth together is 3/8 minus 1/2 cosine of 2x plus cosine of 4x over 8, or times 1/8, however you want to write it. That will conclude this video, and I'll see you in the next one.